Welcome to the session on Converting ER Model to Relational Schema, Part 2. The prerequisites for this session are Basics of Database Management Systems, Relational Data Models, and ER Modeling. Knowledge of these topics will help you to better understand the concepts. This session will take you through the process of converting cardinality and degree of a relationship in an ER model into relational schema. Next, let's look at conversion of relationships in ER model into relational model. We have seen before that a relationship is represented based on two characteristics: cardinality of a relationship and degree of a relationship. We will look to convert cardinalities 1:1, 1:m, and m:(n), and the three common degrees unary, binary, and ternary. When converting a binary relationship of cardinality 1:1, a new column is added in one of the involved entity. The column references the primary key of the other entity. Consider the scenario: employee manages retail outlet. The entity employee is related to entity retail outlet via a 1:1 relationship manages. As seen before, entity employee is modeled to a table in the relational model as shown, and same with the entity retail outlet. Now, to convert the relationship manages to relational model, a column managed by is added to the retail outlet table, which references the primary key of the table employee. Thus, the relational schema for the scenario employee manages retail outlet is as shown. When converting a binary relationship of cardinality 1:m, a new column is added to the table on the m side of the relationship. This column references the primary key of the related entity. Consider the scenario: supplier provides quotations. The entity supplier is related to the entity quotation via a 1:m relationship provides. Based on strong entity conversion, the entity supplier is modeled to a table with columns supplier ID, supplier name, and contact number in the relational model. Similarly, the entity quotation is modeled to the table quotation with columns quotation ID, item ID, and quoted price. To model the relationship provides into relational model, the column supplier ID is added to the quotation table, which references the primary key of table supplier. Thus, the relational schema for the scenario supplier provides quotation is as shown. For binary relationships of m:(n) cardinality, the approach is slightly different. Such relationships require an addition of a table comprising of the primary keys of both the tables it is to relate. Consider the scenario: customers purchase from various retail outlets. The entity customer is related to entity retail outlet via an m:(n) relationship purchase from. As seen before, entity customer is modeled to a table in the relational model as shown, and same with the entity retail outlet. To model the m:(n) relationship purchases from, the table purchase from with columns customer ID and outlet ID is added to the relational model. Columns customer ID and outlet ID refer to the primary keys of the table customer and retail outlet respectively. Thus, the relational schema for the scenario customers purchase from various retail outlets is as shown. Let's now look at the conversion of unary relationships. When converting a unary relationship of cardinality 1:1, a new column is added to the involved entity. This column references its own primary key to enable self-reference. Consider the scenario. Customer is spouse of customer. The entity customer has a 1:1 relationship, spouse of, with itself. As seen before, entity customer is modeled to a table in the relational model as shown. To model the unary relationship spouse of, the column spouse ID is added to the table customer, which references its own primary key. Thus, the relational schema for the scenario customer is spouse of customer is as shown. Conversion of 1:m unary relationship works much in the same way as for 1:1 unary relationship. When converting a unary relationship of cardinality 1:m, a new column is added to the involved entity. This column references its own primary key to enable self-reference. Consider the scenario: employee manages employee. The entity employee has a 1:m relationship, manages with itself. As seen before, entity employee is modeled to a table in the relational model as shown. To model the unary relationship manages, the column managed by is added to the table employee, which references its own primary key. Thus, the relational schema for the scenario employee manages employee is as shown. Conversion of m:(n) unary relationship has a slightly different approach. When converting a unary relationship of cardinality m:(n), a new table with two columns is added. Both these columns refer to the primary key of the involved entity. Consider the scenario: employee is a guarantor for employee. The entity employee has a m:(n) relationship, guarantor for, with itself. As seen before, entity employee is modeled to a table in the relational model as shown. To model the unary relationship guarantor for, the table guarantee is added with columns guarantor ID and benefactor ID. Both these columns refer to the primary key of the employee table. Thus, the relational schema for the scenario employee is a guarantor for employee is as shown. Let's now look at the process for converting ternary relationships. When converting ternary relationship of any cardinality, a table with at least 3 columns is added to the relational model. Each of these columns enable foreign reference with the tables corresponding to the entities that are involved in the relationship. Consider the scenario: customers purchase products from retail outlets. The relationship purchases relates entities customer, product, and outlet. As seen before, entity employee is modeled to the table employee, entity product is modeled to the table product, and the entity retail outlet is modeled to the table retail outlet. To model the ternary relationship purchases, a new table named purchases is added to the relational model. The table has 3 columns. Customer ID refers to the primary key of the table customer. Product ID refers to the primary key of the table product. And outlet ID refers to the primary key of the table retail outlet. Thus, the relational schema for the scenario customers purchase products from retail outlets is as shown. We have just learned to convert relationships in ER model into relational schema. Please solve the lab exercises provided under the topic Converting ER Model to Relational Schema in the lab guide.